So, we are social scientists. And our focus is to identify causal relationships between different independent variables and the dependent variable. And we need to make sure that it is the independent variable that is responsible for the changes in the dependent variables, not something else. The classic example would be shoe size and intelligence. Something could be the cause, the student's age, the student's grade level. The shoe size increases as the students get older. Shoe size increase as students progress from one grade level to another. So make sure we can ascertain that it is the independent variable that is responsible for changes in the dependent variable. Are we clear? So, what do we mean by cause and effect? What do we mean by causation? And how do we determine whether there's a causal relationship between the independent variable and the dependent variable? When we talk about causation, we mean how the change in one variable leads to the change in another variable. How changes in the independent variable leads to changes in the values of the dependent variable. And when we talk about causality, cause and effect causation, there's always a time sequence. Changes in the independent variable has to happen before or prior to changes in the values of the dependent variable. And we have to see how each independent variable, remember how I show you about controlling for, how changes in each independent variable contributes to changes in the value of the dependent variable. We can only look at how changes in one independent variable on the dependent variable by holding constant the values of other variables. We rotate the value of that independent variable from the first value until the last value. When we are done with that independent variable, we hold that variable constant. We move to another variable, the second variable, and look at how changes in the second independent variable contributes to changes in the dependent variable. We rotate the values of the second variable from the smallest to the largest again. When we are done, we hold the first two variables constant. We hold the values of the first two variables constant. We look at how changes in the values of the third independent variable affects changes in the value of the dependent variable. That is what we mean by holding constant. You will learn that mathematically when you take statistics. Eventually, before you graduate. Are we clear? If we don't hold constant, we don't know how each independent variable contributes to changes in the value of the dependent variable. We don't know which independent variable contributes the most, which independent variable contributes the least. Okay, let's look at this. We disaggregate our sample by age group, under 40, 40 and above. If we don't separate our sample by age group, the total for those who did not say thank you when somebody holds the door for them would be 12. The total for those who say thank you when somebody got the door for them would be 18. If we don't disaggregate our sample, our results, as you can see, are less meaningful. We can just say that a higher percentages or more respondents tended to say thank you when somebody got the door for them. When we disaggregate our data, our sample by age, we see a more meaningful pattern. More people, a somewhat higher percentages of folks 40 and above are more likely to say thank you when somebody got the door for them. We see a more meaningful pattern of results. So this is another way we do controlling for, by separating our sample by age group. Okay, let's say maybe separating our samples by age is not enough. We see a more meaningful pattern, but we can further separate our sample by age and gender. Now, a different and more meaningful pattern emerged. When we separate our sample by age and gender, we see yet a different but more meaningful pattern from lumping everything together and concluding that in general, people are more courteous. They are more likely to say thank you when somebody got the door for them. So when we separate our sample this way, by gender and age, we realize that people who are older, 40 and older, middle-aged folks are more likely to say thank you. It's the same. The pattern is the same for males and females. Only a slightly higher percentage of males are more inclined to say thank you when somebody got the door for them. So it's more of an age difference, not a gender difference. As you can see, when we control by age and gender, we find something new when we do it this way. Are we clear? By age and race, we forget about gender for a while. We control by age and race. We also see a pattern. Not for all racial groups, but only among the non-whites. We don't see an age difference for both racial groups, but we see a racial difference. When we divide our sample by age and race, we see a race difference. Non-whites are more courteous in this case, regardless of age. So sometimes when you have a sample, when you have a data, if you have enough cases, you keep dividing your respondents into different groups. Sometimes you see different patterns. So this is what we mean by controlling for. And if we want to control for three things in here, age, race, and gender, because we know we can only portray two dimensions, we have to have a different table, one for male, one for females, and the two tables have the same information, the same structure, one for males, one for females, if we want to control for three independent variables. Any questions?